Good morning and good afternoon. This is Monica Paolini from Sensafili, and today I'm talking to Art King at SpiderCloud Wireless. He is Director of Enterprise Services and Technologies, and this is a conversation for a report on densification and the evolution in the RAN and how it is changing as we see more small cells, DAS, and Wi-Fi and other technologies spreading to increase the capacity of our wireless networks. Art, thanks for being with us today.
Yep, pleased to be here, Monica.
So let's get started, and maybe you can tell us a little bit about what SpiderCloud Wireless is doing and what is it you're doing personally in that context.
Okay, so SpiderCloud Wireless builds indoor cellular systems. We call it the Enterprise RAN, and it's a small cell technology with Ethernet in the front hall within the office building, radio nodes distributed through the building, very similar to the type of footprint you'd see in a contemporary Wi-Fi network. And we have a services node in the kind of the telecom heart of a building that coordinates the cloud of radios and then ties back to the mobile core via high capacity IP backhaul. My background is I came from the enterprise space, so I got to learn about the wild world of cellular over the last 3 years, and I do the marketing, evangelization, a lot of writing, and a lot of public-facing activities for SpiderCloud, and get to interact a lot with both our customers and our engineering organization, and the analyst community and press.
I think it might be worth giving a little bit of a sort of historical introduction here, a perspective in terms of the enterprise, because enterprise is clearly a major part of the client base for any mobile operator, and yet has been a segment that has been somewhat neglected as a specific in terms of coverage of the enterprise. And so maybe you can tell us a little bit more about how is that, how do you see that evolving?
Well, the enterprise hasn't been neglected per se. There was a lack of cost-effective technology to address buildings maybe under about 500,000 square feet. And so within the higher end, there's quite a few buildings that have been lit by DAS infrastructure, but there was a lot of buildings that were too small to have the kind of the fixed cost work from a business perspective for both the operator and the customer. So small cells are opening the total addressable market to a whole lot of smaller office buildings that just weren't available in the past to be improved. The DAS infrastructure, when you build a big wideband antenna through a building and then plug base stations into it, just that model didn't work for smaller buildings. So we're bringing essentially technology in to address the unmet needs of the subscriber buildings from say 50,000 to 500,000 square feet.
Yeah, and that's a huge market, because we always hear about stadiums, big campuses, and all that obviously are the first targets. But then as you go down, it's like a pyramid. You have many more buildings, but smaller and more difficult to address from a technology point of view. Now we have the technology. How is it that small cells can help address that market specifically, the smaller buildings?
Well, with the small cell, you've got a essentially standard 3GPP cellular technology, but you're talking let's say a 10,000 square foot coverage footprint. So in the case of like the Verizon technology that's being implemented, what we're doing is reusing 30 megahertz, band 4, band 13. Just reusing 30 megahertz over and over again, in the same building. So you get a lot of, spectral reuse and, extremely high capacity, because that instead of having that spread out over, X square miles, it's only over 10,000 square feet. So it kind of it changes the needs around, the spectral crunch and a lot of the things the operators are struggling with by making the cells extremely small.
Yeah. So in the case with Verizon, how is you obviously are reusing spectrum, so you increase the spectral efficiency of the same asset.
Right.
Can you tell us a little bit more how you do it, because physics is still physics, and so you need to manage the interference somehow because you're sharing the same spectrum, right? How do you deal with that?
Well, there's the combination of standard cellular, technology. I mean, cells were designed to interfere and have cell edges. I mean, it's just the nature of the technology. And, what we've obviously built a lot of intellectual property around our platform to, enable that to be, a better experience for the device owners. At the end of the day, the asset test from the operator community is really meeting KPIs. And, I don't have, not being a PhD in engineering, the nuance of how it's really done is kind of, beyond me. But the KPIs and the satisfaction of both the enterprise customers and the operators and the technology, I think, is kind of the core message that we have solved a lot of these problems. Mainly because of, you can tell that through customer satisfaction. Mm-hmm. And a huge amount of automation has been done in the SON, the self-organization, self-optimizing software in our services node that kind of coordinates the cloud of radios to kind of have the network do a lot of work to keep itself somewhat tuned and aligned and in harmony with the macro network on the outside world.
Yeah. Well, and the other thing is that not only the user, the subscribers within the enterprise and the enterprise as a customer are happy, but by doing that, by enabling them to use a local network, you also offload the macro network. So that means that the macro resources are free to be used for the wider area. Can you comment on that? Because oftentimes, we just focus on one or the other, but it's actually the two together that bring value to the operator.
That's been one of the discoveries, or not a discovery so much, but it's been an internalized change in thinking in some of the market RF engineering groups, where indoor and outdoor were always looked at as two parallel things. And when you started seeing, in an indoor system, drop macro usage by 50%, light bulbs start going on, where people start thinking about doing holistic engineering. And when they look at a macro upgrade, you start looking at the dollars and saying, that enterprise building right there generates a hotspot in the macro. There's 1,000 people there. What's the cost of doing the macro upgrade versus maybe offloading them to a small cell infrastructure and getting them off the outdoor network? So you're seeing the emergence of not only densification as a capacity and performance move, but also as a way to manage your spend on the outdoor network at the same time.
Yeah, and that changes the performance. So there is the offload part, but that the second step is that the business model also changes because it becomes a little bit more an end-to-end business model. But the business model is nevertheless still a challenge, and I would say it's more of a challenge than the technology, because the technology is there available, but the business models have been a little bit more difficult to develop because it's unclear who is going to pay for the infrastructure. How do you manage it? What are your latest thoughts on that?
We're seeing both. We're seeing operators that are saying we will certify and allow SpiderCloud to be connected to our network. And any reseller who wants to build out a network, or any enterprise that wants to build out a network, as long as it's to our specifications and done by one of our system integrators that will do a sanctioned high KPI installation, go for it. And then there's other operators that are saying, we want to build and manage all the pieces, and that obviously has its own kind of capital impact and business process impact. I think the bigger picture that is emerging is as people have less concerns about co-channel interference, because that's one of sometimes the big issue with releasing the reins of control is more a bad installation or a surprise installation might cause co-channel interference with the macro. So as more experience happens within an operator, they start becoming more comfortable with saying, yeah, let's let the installations happen a little bit more freely, because we know that the technology doesn't interfere with the outdoor network. So it's people naturally start very conservative, because the RF engineers are held accountable for the KPIs and the performance of the network within their geography. So I understand their concerns, but over time, things start, releasing to where you have the ability to, to sell to enterprises and fulfill it. And there's less of a concern about, interference on the outdoor network.
Yeah, yeah. Now, there is a lot of talk of neutral host type of arrangements. In that case, who do you see as the emerging neutral host, the sort of entities in the middle that facilitates all of this?
You've got large entities like Extenet,
Mm-hmm.
Crown Castle, American Tower. A lot of the traditional tower companies that are proposing to do small cells. I've seen host neutral Ethernets being proposed, where you can plug in small cells, and because they're being installed above a ceiling, there's no aesthetic issues with multiple radios. And we've also seen enterprises that are basically saying we need cellular service indoors now. And what we're going to do is we're going to converge on one mobile operator. And as part of our contract with that operator, we're going to request an allowance for small cells to light buildings up that don't have satisfying performance to our business users. So you're seeing both people talking about host neutral,
Mm-hmm.
people thinking about host neutral in the context of like the Multifire in the future,
Mm-hmm.
but also enterprises that are saying, I know I can't get that now, but if I converge onto one operator and manage my contract with them, I can satisfy my business people.
Yeah. You mentioned Multifire, and that's an interesting development in the old densification universe. So there is LTU, unlicensed, LAA, LWA, Multifire. There's all sorts of things, but clearly what that tells you is that the unlicensed band, it's very interesting to mobile operators for and if, especially in indoor environments. What's your view on those different solutions?
The Multifire in particular is, so if you look at, let's back up a little bit. So licensed was running out of steam. So you didn't have enough spectrum to keep up with like downlink utilization by the customers. So you added LAA to give that boost downlink capacity of in the unlicensed spectrum essentially. But beyond that, with Multifire, you're operating both uplink and downlink inside the unlicensed spectrum, and in a friendly manner to not stomp on Wi-Fi, or you're operating it in the 3.5 gigahertz spectrum and avoiding the issue completely. So it's a great way to solve the neutral host problem by, instead of building the wideband antenna and doing base stations, you converge on the same piece of spectrum, and you converge on the same access method to the spectrum. And Multifire is being engineered to live in a contention-based environment where you can have multiple Multifire instances running in the same piece of spectrum, but you could also have a Multifire single infrastructure that connects to multiple mobile cores. So 5 gigahertz, why is it interesting? It's a planetary band, and that's, imagine if every UE in the world had a 5 gig radio and Multifire, and it was available around the planet, it would solve the indoor problem for the world in one, in kind of one equation. So that's obviously recklessly optimistic and forward looking, but you can see the end game being a great simplification of indoor infrastructure.
Yeah. Well, and as you say, well, the fact that you can have the same infrastructure shared by operators and fully integrated with their network makes it easier from the operator end. So
Yes.
it allows you a more efficient use of the spectrum on the access level. So that's, but at the same time, that looks like it's going to coexist with Wi-Fi. It's not so much an alternative. It's just like we need to get the best out of the spectrum that we have, and we have multiple technologies. Would you agree to that, or is it more like competition within the enterprise?
No, it's not competitive. The enterprise is like this kind of, you envision the yin and yang kind of circle. you got Wi-Fi and you got cellular, and we had one of our advisors, the enterprise guy, basically say very clearly, I don't want to be a Wi-Fi provider. I want to be a wireless provider. So he was very focused on satisfying both kinds of wireless for his business people, because they were pushing hard for full service on all pieces of technology. Yeah. And in certain environments like medical, where you're wildly overloaded in your Wi-Fi infrastructure, they're looking to unload Wi-Fi by getting a lot of the mobile devices off of Wi-Fi somehow.
Yeah, and that's from a subscriber, from the user point of view. You have wireless is the rule today. So the question is, what technology? And as a user, you don't care, and as a vendor, as an enterprise or operator, you just have to find new ways to meet that demand. So now, as we get to onto 5G, and even before 5G, there is a lot of talk of using different bands. All the way to 60 gigahertz, 70, 80, you name it. What is the scope for those kind of bands with much more limited coverage for indoor coverage? Because that seems like it's perfect, right? You just have the small hotspots.
What we're hearing on the product management side of our organization from the CTO community is the operator community is looking at sub 6 gigahertz being indoor. And the very high millimeter waves are going to be outdoor solutions. So they believe that what's going on indoors right now with under 6 gigahertz, because of the sheer cost of building wireless access points that at a microwave frequency, and having to put a huge amount of them in with cabling, it kind of blows up the business case. So the idea of the sub 6 gigahertz, because it can generally propagate through walls and has decent indoor characteristics, that will continue to be the direction, with the very high frequencies being more of an outdoor solution.
Oh, okay. So you see more of the outdoor, but I guess because in the indoor you can reuse spectrum enough that you have enough capacity. So you don't need much more in terms of, especially if you have the 3.5, because the 3.5 is going to be it's going to be a major opportunity for indoor coverage, because as I say before, there is no issue with the macro.
Yeah, definitely. Without any co-channel interference, the 3.5 gigs when you hand in, you hand into a completely different frequency, so you're not worried about the outdoor interference.
Now, another new development is MEC, mobile edge computing, which allows you to push to the edge, and a lot of the applications are actually specific to a location, not just diffused through the network. Right. What's your view? Is that going to be relevant to the enterprise?
Yes. I think it could potentially be more relevant in the future as enterprises buy their own RAN equipment, instead of, because right now MEC is going to be an operator controlled infrastructure, because the RAN is controlled by the operator. When MEC becomes a relevant box to an enterprise that they can buy from a Cisco or an HP and bolt into a rack and connect, it could start being very interesting from the enterprise perspective. We're seeing plenty of traction and business interest right now with MEC, and in the context of what we're doing, it's just inserted in the S1 link between the RAN equipment and the core, and that can be either through through a virtual machine where we pass the traffic up to the VM and then back to the core, or in an external box. So we've seen MEC being used both ways. We've done quite a bit of prototyping with various software vendors, but the people that are in the lead in the discussion are very much the ones that are looking at it, all the holistic operating environment, the maintenance, the patching, everything necessary to run the whole life cycle of MEC. Mm-hmm. And the folks that have thought through what the killer apps are that will justify decomposing an application out of a cloud data center into the mobile edge. So this isn't a data center at the edge of the cellular network. This is MEC is going to be a purpose-built kind of thing that has business value being at the edge, and it isn't just put there because you had some spare compute capacity sitting in an enterprise rack.
So what are the applications then? Well, what is that for an enterprise? So what is it they can do with MEC?
We've seen caching, local breakout, and a number of applications around the unified communications integration, so that a lot of the native infrastructure on a mobile device can be used with the enterprise infrastructure. And one of the funny things is it drags the network behind it. There's retailers out there that are in the bricks and mortar space that want to go to wireless point of sale on tablets and essentially mobile devices within their stores, and they're seeking clean spectrum to operate in, instead of fighting in the mall with all the SSIDs and all the adjacent shops and all the adjacent wireless APs. So there's high-end retailers that are really looking at, how can I move all this to LTE and get out of the traffic jam that I'm in right now, that can cause me to not be able to complete a sale and have to go to like a wired cash register because the iPad stops working when you're trying to take a customer order.
Yeah, and at the same time, all those communications are local, in the sense that they are really within the premises. Exactly, effectively, right?
Yeah. I was in a situation where a hospital was saying that from a HIPAA perspective, they want to use LTE, but they can't loop that customer data out of the hospital through the mobile core and back to the tablet because of HIPAA regulations, and whether or not that's a misreading of the situation or not, they were very clear that they had to keep that data in-house, and they felt it was imperative to do it. It was a hard requirement. So they were saying, how do I do private LTE, or how do I do it on the operator's LTE, but break that traffic out and send it to my data center inside my building?
Yeah, actually, that reminds me of another issue about regulation, about safety, security, emergency calls. How do we deal with that when you are in an indoor environment?
So for our technology, when you the cell size and what we're doing with our cells, each cell has its own ECGI, so it's very identifiable from an LTE perspective. And when you look at average cell spacing of, say, 100 feet between cells, we're very much able to assist an operator in meeting the FCC requirements of a call must be located within 50 meters of the person that generated the emergency call. So the ECGI and the information that we attach in when the radio is installed, as far as what floor, what zone on the floor, it provides what the FCC calls a dispatchable location, so that emergency services can get, within the requirement of the FCC.
Yeah. So what is it you guys are working on, and for the, say, next 5 years or so? What is it we should expect to see that it's new from SpiderCloud?
Next 5 years. Right now, there's the big things in the pipeline are the the LTE trials and the things that are going on with Verizon, and there's a huge amount of interest within the operator community. That's our installed base, because they haven't built any Wi-Fi infrastructure, and there was a reluctance to build a whole parallel separate mobile core infrastructure to tie in Wi-Fi authentication. So the emergence of LTE has generated a lot of interest in the operator community kind of around the world for us. And the other part of the things that we've got going on is just executing the business plan, and kind of scaling up and kind of turning the flywheel to get a lot of the operators that we have already in place, helping them get to higher volume, and helping the system integrator channels get more and more efficient, and better at deployment and that type of thing. So it's a lot of kind of basic business blocking and tackling to make the machine go.
Well, that's a good place to be. So Art, well, thank you so much for sharing your insights with us today.
Okay, thanks, Monica.
Okay, so this was a conversation with Art King at SpiderCloud on densifications and what the new RAN is going to look like. Thank you all for listening to us.